Talk about investigating roots of polynomial functions. And yesterday we talked about the turning points and the roots and the end behavior. And we're going to kind of integrate that into our investigating today. And it says for each function, use your graphing calculator to sketch the graph. And then we're going to figure out how the graph behaves at each x-intercept. We're going to state the degree, the number of roots, the x-intercepts, and the behavior of each x-intercept, whether it touches or crosses the x-axis. So if you need to use your graphing calculator for this first one, feel free to use it. But in this particular case, I like to say, well, slope-intercept form. And what happens is that b is -5. It's the constant of this value. And our slope is the number in front of the x, which is 1. And in fact, it's going to be 1 over 1. So we come over here, and again, you can type this in your calculator if you prefer, but we start down here at -5, and then it's going to be up 1 over 1, up 1 over 1, rise over run. And in particular, what we're looking for is we're looking for the x-intercept. But here's our graph. And in this particular problem, y, or f of x equals x minus 5, has degree of 1. The reason it has degree 1 is because the exponent on the x is 1. And what we see in the picture then, because the next part says the number of roots or solutions, well, here's our root or our solution, which is also known as an x-intercept. We have one root or solution. And it happens to be here at 1, 2, 3, 4, 5. And what's happening to our graph here at this intercept is that it's crossing. We've got part of the line above our green point and part of the line below it, so we say that we're crossing when we look at how it's behaving at the x-axis, at the x-intercept. When we look at problem number 2, f of x equals x minus 4 times x minus 4, well, we've got x minus 4 times itself, and we could rewrite that as x minus 4 squared. And in fact, when we write it in this format, it tells us what the degree is. And the degree is on the parentheses, which is 2. To come up with our roots here, or our x-intercepts, or our solutions, what we can do is we can take our values in our original function, and we can set them equal to 0. And what we do, we add 4 to both sides. And we get x equals 4. We add 4 to both sides. And we get x equals 4. So even before we draw the picture, what happens is we get x equals 4 and x equals 4. We'll draw the picture momentarily on our calculator, although I hope we're fairly familiar with this. But what we can see is that we get x equals 4 for both of them, so that means that there's going to be 2 roots or solutions to this problem. It just so happens that they're going to be the same root in this particular case. And let's look at what this looks like. I'm going to type in the simplified version, but you can type in the original function. And here's our picture, and we're sketching. We don't have to draw a super precise graph. But what we do want to be precise about is the x-intercept here. And here's a picture. At the value of 4, does our graph cross or does it touch the x-axis? And what we can see is that it touches. Again, we do have 2 roots, it's just that they are a repeated root because we have squared in this problem. Problem number 3. Our degree, well, we have an x to the first in our first parentheses, we have an x to the first in our second parentheses, we have an x to the first in our third parentheses. It actually ends up that our degree is 3. And if you remember from yesterday, what we talked about is whatever the degree of the function is determines how many roots we're going to have. So since we have degree 3, we're going to have 3 solutions, 3 roots, 3 x-intercepts. And where those roots come from, even before I write the simplified version, is you can take x minus 1 and set it equal to 0. And x plus 3 and set it equal to 0. And x plus 3 and set it equal to 0. And when we do that, add 1 to both sides, so we get x equals 1. We get x equals negative 3. And we get x equals negative 3. And hopefully you don't have to do those steps. But on the other hand, if you need to do these, that's fine. It helps us identify x equals 1, x equals negative 3, and x equals negative 3. So there we can clarify. We said that our degree was 3, and our roots are 3, so there we've listed all 3 of the roots. If we write this in simplified form, there's nothing that we can do with the x minus 1. But the x plus 3 times x plus 3, that's x plus 3 times itself, is x plus 3 squared. And we can type this into our calculator to get our picture. The nice part is, even before we do that, we can put a root right there at x equals 1. And we can put a root here at x equals negative 3. And once we've done that, once we get the picture, then we can identify what's happening at those places. Are we crossing or are we touching our x-axis? Again, when you type this into the calculator, you can type in the original function, or you can type in the simplified version. It does not make any difference. X minus 1, and then x plus 3 squared. And here's our picture. So we're going to sketch that. Again, we're not going to be too specific here on our graph. Put it roughly. It looks like that. We want the sketch so we can identify, does the graph cross or does it touch the x-axis? Well, at 1, does it cross or does it touch? And it actually crosses. We've got a value that's above the x-axis. We've got a value that's below the x-axis. But at negative 3, what we see is that it only touches. We don't go above the x-axis. All our values are below that point. So we flip our paper over and we look at this fourth one. I'm trying to go fairly quickly on this because I want to get spend our time on the summary, but we don't have to go too crazy here. But if we take a look at this again, what's the degree of this function? Well, there's an x to first in this first parentheses. There's an x to the first in the second parentheses. There's an x to the first in the third parentheses. There's an x to the first in the fourth parentheses. There means that our degree here is going to be 4. We've got 4x to the first. And if our degree is 4, then the number of roots that we have are 4. Now sometimes what happens is we have repeating roots. Where our roots are coming from, and again, I hope you can look at this and come up with the answer, and you might want to write at the top of your paper because there's not that much room underneath this problem. But it's x plus 2 equals 0. And x plus 2 equals 0. And x minus 2 equals 0. And x minus 3 equals 0. So we subtract 2 from both sides. And get x equals negative 2. And again, there's people that don't have to do that step. You can just look at the problem. But I do want to show where it's coming from. So we get x equals negative 2 again. And we add 2 to both sides to get x equals 2. and we add 3 to both sides to get x equals 3. So our 4 roots here are -2, -2, +2, and 3. And we're going to mark those on the graph. I know I'm kind of going out of order on these, but here's -2, here's +2, and 3. In fact, if you're ahead of me, this picture isn't going to completely fit on the graph, but really what we're focused on is what's happening to our roots here. The simplified version, well, we have x plus 2 squared, and then we have an x minus 2, and an x minus 3 that we can't condense down. But we can type this into the calculator to get the picture, and we already have a good start on the picture. So we clear this out, and we type in x plus 2 squared times x minus 2 times x minus 3 and again, it doesn't completely fit on our graph, but we can make it work. When we draw our picture here, we've got something like this, then it goes off the graph, and then we start back up here. And again, it's a sketch. And the most important part here that we're looking at is the x-intercepts and what's happening to the x-intercepts. And now that we've got the picture roughly drawn, at least the part that we can see, at -2, does our graph touch or does it cross? And what we see is that it touches. But at our other two intercepts, x equals 2 and x equals 3, the graph actually crosses the x-axis. And if you're really paying attention, you see the pattern now. If we go back for a moment here, with the x plus 2 squared, we came up with the roots -2, and it touched. When we had x plus 3 squared, our root would have come from the -3, and it touched. X minus 4 squared, it touched there. So in other words, when we see this squared, it looks like we're going to have a touch process. As we move here into the fifth example, we've got x times x times x times the quantity of x plus 3 times the quantity of x plus 3. If we want to identify the roots, even before we deal with anything else, it's x equals 0, and x equals 0, and x equals 0. And then we have the x plus 3 equals 0, and the x plus 3 equals 0. And again, there's not a lot of space. You could probably fit that in underneath the graph if you want to write that down. But I'm also hoping that you don't have to write that down. But this tells us that x equals 0 3 times. We have a repeated root. Our other root is coming from the x plus 3, so we get x equals -3 when we subtract 3 from both sides. So when we go back up here, first of all, another way of looking at it is we've got x equals 0, x equals 0, x equals 0, x equals -3, x equals -3. We have 5 roots. And consequently, if we have 5 roots, that must mean that our degree is 5. If we write this back in, the simplified version, we get x cubed times x plus 3 squared. And we've got a strong guess here that with the x plus 3 squared, that we're going to touch. So let's make sure that I didn't just circle something wrong. So we're going to type that in to our calculator. And we have x cubed times x plus 3 squared. Picture's a little bit wacky, but it does fit on our screen. And as we draw that here, I don't know why I didn't put that in already, but I've been putting the roots in first. We've got our 0 here and our -3. As I look at the picture one more time, sure enough, we touch here at -3, just like we thought. And then we go over here at 0. It looks like we cross. Again, at this point, I think you can make another inference, which is that when the exponent is even, we touch. And when the exponent is odd, we cross. Let's test our theory on this last picture here before we summarize what we've got. So we've got x minus 2 times x plus 3 times x plus 3 times x minus 1 times x minus 1 times x minus 1. I'll go in order this time. And what we have is in simplified form. We've got x minus 2 times x plus 3 squared times x minus 1 cubed. In terms of our degree, we've got 6 parentheses. And each parentheses has an x to the first in it. So that means that our degree is 6. And consequently, if our degree is 6, then that means that we're going to have 6 solutions or roots or x-intercepts to this problem. The roots come from each of those parentheses. See, x minus 2 equals 0. And we can add 2 to both sides. So we get x equals 2. I'm not going to write this down 6 times, but the next different root is the x plus 3 equals 0. So we get x equals -3. And if you notice, we've got 2 parentheses that have that in there, so we're going to have a -3 and a -3. And then we've got x minus 1, x minus 1, x minus 1. Well, x minus 1 equals 0. We can add 1 to both sides, and we get x equals 1. Here, here, and here. And now let's do the best we can to draw a picture. We should be able to see most of the picture on the screen. And in this particular case, x minus 2 times x plus 3 squared. Got to get that typed in correctly though, and this is not going to be easy. One more time. X minus 2 x plus 3 squared and x minus 1 cubed. Finally, gives us our picture. Again, we can't see it very well, but we can put our roots on our picture here even before we typed it in the calculator. We've got a root here at 2. We've got a root here at -3. And we've got a root here at 1. Looking at the picture one more time, it's a pretty tight squeeze over here to the left, but we can get it. And the nice part is it's a sketch. But we don't have to get it exactly right. And then it kind of goes up and then it comes around and then back down. So not my best picture, maybe better off here, but I did try to get, see how there's a little curve in that graph at 1 and then back up. I tried to get that in there. Did not do well, but that's the beauty of having a graphing calculator, is that we can look at the picture on the screen. So there is our picture as we answer the questions, and we probably could have beforehand what happens at our various intercepts. And at x equals 2, we cross. At x equals -3, we touch. At x equals 1, we again cross. So let's see if we can put this into our final statements here. Well, what is the relationship between the degree and the number of the roots? They are the same. It says, is there a relationship between the degree and the number of unique roots? So that means each separate root, no repeats. And the thing about degree is it just tells us how many roots we're going to have. That's all that the degree tells us. The degree tells the maximum number of roots. We've already kind of discussed the next questions here. I don't want to get too far ahead. I want people who are writing this down to get this down. But we have already talked about back that. In general, all factors with even what it's called multiplicities. Even multiplicities like x squared, they're going to touch the x-axis. And factors with odd multiplicities, 1, 3, 5, are going to cross the x-axis. When we have a factor that's a multiplicity of 1, it's going to look linear at the x-intercept. So I tend to draw that for my line. Factors with multiplicity of 2 will look quadratic. Quadratic is a U-shaped curve, which is why they touch. And factors with a multiplicity of 3 will look cubic at the x-intercept. And we looked at the graph in our previous notes of a cubic function. It looks like that. Back to the parent function of a cubic. And if you're curious on your calculator, you can just type in y equals x cubed and you can look at it. It'll be a little bit more precise picture than what I have. And as we get close to finishing, count the total number of multiplicities for each of the functions in 1 through 6. So I've kind of given it away. But if we scroll back here to number 1, our multiplicity is simply the degree of this function, which is 1. Well, let's do 2 here before we write down. Multiplicity for number 2 is coming from our exponent on our function, 2. Before we look at these other ones, let's write those 2 down. So we have 1, we have 2. Multiplicity for number 3. Well, the multiplicity on x minus 1 is a 1. Multiplicity on x plus 3 is a 2. And 1 plus 2 will give us 3. You can probably guess the answers to 4, 5, and 6. But I do want to point them out. The exponent on the first parentheses is 2. The exponent on the second parentheses is a 1. The exponent on the third parentheses is 1. 2 plus 1 plus 1 is 4. Number 5. Exponent on the cube, on the x is 3. Exponent on the parentheses is 2. 3 plus 2 is 5. Exponent on the x minus 2 is a 1. Exponent on the x plus 3 is a 2. Exponent on the x minus 1 is a 3. 1 plus 2 plus 3 is 6. So we've got 4, 5. And finally, the sum of the multiplicities of the roots is equal to the degree of the function.